All right, up until now, we've written the equation of a line in point-slope form, given a point and a slope, or 2 points, or a table, or a graph. So again, write this down, y minus y1 equals m times x minus x1. That's the formula that we've been using. So what happens if I get my equation in point-slope form, but then I want to turn it into slope-intercept form? So let's look at this problem right here. We have the information, a point is located at 4, 9, and the slope of the given line is 5. So again, we want to label our values, x1, y1, and then our slope, of course, is our m value, right? So we know y minus y1 equals m times x minus x1. Y minus y1 equals our slope, which is 5, times x minus our x1 value of 4. All right, so this is point-slope form. Now, in order to write our equation in slope-intercept form, which is y equals mx plus b, we have to isolate our y value, and we also want to get rid of our parentheses. So let's go ahead and cut our equation down the middle, or in half, and work one side at a time. All right, so I need to get rid of these parentheses. So I've got to distribute this 5 into all values of these parentheses, right? So 5 times x gives us 5x, and then 5 times that minus 4 gives us our minus 20. And we didn't do anything to the left side of our equation, so we'll just bring down this y minus 9. So we've gotten rid of our parentheses by distributing the 5, but we still have to get this y by itself, but then the minus 9 is right there. And the inverse or opposite operation of minus 9 is just plus 9. So let's add 9 to the left side of our equation, which means we need to add 9 to the right side of the equation. Now just make sure you line up your terms neatly so you don't cause any error. And we have y that we just bring down. Minus 9 plus 9 cancels to 0. And we've got our equal sign. And then the 5x it's not being combined with anything, so we bring that down also. But I can combine these constants, negative 20 plus 9, and that gives us a minus 11. So our equation in slope-intercept form is just y equals 5x minus 11. So our y-intercept crosses our y-axis at negative 11, and our slope is a positive 5. All right, let's try another one. Let's look at this problem right here. If I'm given the point negative 5, positive 9, so here's x1, y1, and we're given the slope negative 2/5. So let's write our equation in point-slope form first. So we have y minus our y1 value of 9, and that should equal our slope, which is negative 2/5, times our x value minus a negative 5. And again, minus a negative 5 really means plus, so we're going to say plus 5. Remember, anytime you sub in your x1, y1 values, the signs always switch when they're inside the equations. It's y minus 9, and this turns into an x plus 5. All right, so let's get rid of our parentheses and isolate our y value. So I'll separate my equation into 2 equal pieces. And this negative 2/5 times positive x gives me a negative 2/5 x. And then negative 2/5 times positive 5 gives me a minus 2. You can use your calculator, or just remember that when you're multiplying fractions, you multiply numerator times numerator, denominator times denominator. That 5 can be written as 5 over 1, and then of course your 5's reduce, and you're left with that negative 2 or minus 2. And then the left side of our equation, we just bring down our y minus 9. So I still just need to isolate that y value, and the opposite of minus 9 is plus 9. So let's add 9 to both sides of this equation. And we bring down our y, and then of course minus 9 plus 9 goes to 0, should equal a negative 2/5 x. And then negative 2 plus 9 gives us our plus 7. So our equation in slope-intercept form is y equals negative 2/5 x plus 7. So our y-intercept is positive 7. That's where our graph crosses the y-axis. And our slope is negative 2 over positive 5.